All right. Day 3, you've made it till Friday. I'm so proud of you guys. But we're going to keep going. You're going to get a video pretty much every day because I don't have a lot of work for you to do just yet. So be happy about that. But please continue to watch my videos and comment. I love reading those. So, I think we left off last time with a graph. Okay? So today we're going to start with the graph. Maybe not that exact one, but one that we saw not very long ago. Okay? We saw a graph. We did a y equals x squared graph, correct? Y equals x squared is going to look something like this. Now, I need you to answer a question. Is y equals x squared a function? We answered that the other day. Yes, it is a function. Okay? Is y equals x squared a 1-to-1 function? Remember which two tests it had to pass? It had to pass the, what were they? The vertical line test. It passed it. It's a function. Did it pass the horizontal line test? You're right. No, it did not. Y equals x squared is not a 1-to-1 function. Why are we doing this again? Well, sometimes, like with our trig functions, I need to know, can we restrict the domain to make it be a 1-to-1 function? Okay, y equals x squared gives me all the x's and all my y's. Okay, there is no restriction on the domain, on the x values. But what if I could make a restriction on my x's and y's? Okay, what if I wanted to graph a different function? What if I wanted to graph y equals x squared where I restricted my domain? Okay, I'm going to write this in interval notation. So my x's, my domain, the x's would only go from 0 to infinity. Okay, we'll talk about this bracket and that parentheses also. Let's actually stop and talk about that. Okay, when we are restricting a domain, okay, that 0 infinity is not a point. It's the x values. Some places in Algebra 2 you would write all real numbers. Okay, that's from negative infinity to positive infinity. Okay, now I'm restricting it. When I put a bracket, it means it will equal or can equal. Okay, that's like that x is greater than or equal to. Okay, so I could have said x is greater than or equal to 0. Okay, when there's a parentheses, that means it will not equal. Okay, so I can put x to be less than infinity. This is another way to write the exact same thing. Okay? Right here, this is called interval notation. Let's put my whole hand on the board. Sorry. Which we will be talking about a lot in this chapter, interval notation. They show you in your book, you see a lot of brackets, okay? Brackets and parentheses, okay? So if I wanted to restrict my domain for my x's only from equal to 0 through infinity, okay? I'm going to go look at my other graph, the one where I have already drawn y equals x squared. What am I excluding from this graph? Yeah, everything this side of x equals 0. So I'm taking away that half of my graph. Okay, Okay? So x is 0 is right there. Infinity is that direction. Okay? So my graph of y equals x squared with a restricted domain starts at x equals 0. And it's going to go over. I mean, heavens, if x equals 1, what does y equal? You plug it in. 1 squared is 1. So that point's going to be there. What if I plugged in a 2? Okay, without plugging a 2 to y equals x squared. So my 1 was 1 squared. My 2, 2 squared. What's my y value? If I plug in a 2, I get out a, that's right, 4. If I had plugged in a 3, so I plug in 3 for x, I get a 9. I'm going up, what? Exponentially. 9. There's a 9. Way up here, I'm off of my graph. Imagine that. Okay, is it going to keep going? Exponentially until x gets to infinity. That's why we draw the arrow. Okay? So, is my y equals x squared with a restricted domain a one-to-one function now? Yes. Yes, it's a one-to-one function. So what does that mean? That means it has an inverse. Okay? If it has an inverse, then we can graph its inverse. We can write its inverse function. Okay? So I'm going to go to the next page, and we're going to graph that. I'm going to bring my graph back over. Okay? And I'm going to draw 2 of these because I want to graph the inverse and the original. Even though I just graphed the original, you don't have to graph them both twice again. Okay, I just want you to be able to see my y equals, it's helpful if I get off the lines. Okay, my y equals x squared with a restricted domain. Okay, now I have to put that there. Okay, move this line over just a little bit. Move this line down because I already found that I'm running off of it. Okay, so we know it starts at 0, 0. It goes over to 1. It goes up to 1. It goes over to 2. It goes up to 4. I know it's not drawn to scale. I'm sorry. I'm sure yours is. 8, 9. I'm over at 3, 9. Okay, I'm just giving a few points. Drawing my arrow because it's going to infinity. Okay, what in the world would the equation be of the inverse function? Okay, I'm going to move these lines a little bit. 1. Okay, so that gives me a little bit more room at the top. So what in the world is the inverse function? Okay, so I've already got y equals x squared, looking back to our step 1, 2, and 3. It's already written as y. I don't have to change out the f of x. But I do need to switch the x's and the y's. That was our step 1. What was our second step? That's right, you have to solve for y. So y squared, how do you undo the squareds? Yeah, we're going to take the square root. So y equals the square root of x. Okay? Now, what does that look like? I'm going to do that table. Okay? If x is 0, what is y? What's the square root of 0? 0. And I'm going to plot a point. What if x is 1? Plugging in a 1 for x. What's the square root of 1? That's right. It's 1. It doesn't look too different now. The first 2 points are the exact same. Okay? What if I plug in a 2? Do you know the square root of 2? I don't know the square root of 2, but I'm going to put it here Oh, sorry, if I plug in a 2, we get the square root of 2, which is like 1.41 something. I don't know. Okay? I'm not going to plot that because I can't plot decimals. I can barely plot numbers that are whole numbers here. But what if I pick numbers? Can I pick any number I want to plug into my table? Of course you can. What if I pick 4? If I plug in the square root of 4, do I get an answer? Yes, we get 2. So I'm going to plug in my x value to be 4. And I get an output of 2. Do I want to plug in 5 or 6 or 7 or 8? Oh, wait, what about 9? Could I plug in 9? What is the square root of 9? And we all said that is 3. So if I input 5, 6, 7, 8, 9, my output will simply be 3. Is that enough? What does this graph look like compared to our original function? Okay, now that very first definition we wrote doesn't make such crazy sense. The inverse, the f negative 1 of x equals the y x, such that xy is in f. Okay, so let's look at this a little bit different. Okay, so in my original function, I have the point here that is 2, 4. Okay, that is my original function, xy. But in my inverse function, that's translated to a yx. Do you see this point right here? Maybe that's not too much the same color. What point is that? That is 4, 2. Do you see my x's and my y's have simply switched places? Does that work for all of them? Of course it does. What is this point right here? I'm over at 3, up at 9. 3, 9. What is this point right here? 9, 3. So I can give you a graph with just points, and you can graph the inverse function if you're just given the coordinates x and y. If I had graphed these on the same graph, it would have been a little bit more obvious that they were just reflections across the y equals x. Okay? But Miss Evans, you didn't talk about the other points. 1, 1, does it correspond to? Wait, can I switch my x's and y's? No, it's 1, 1. 0, 0 is going to be the same. That's why I can't just give you those 2 points. That doesn't help you at all. You need some where we can switch them. Okay, so here's a practice problem. If I simply give you an x, y graph, and I plot some points and plot a 1-to-1 function. Okay, so here we go. I have to kind of pay attention. Actually, I'm going to put this, I'm going to undo and put this on an actual graph, because then that will make it a lot easier for you and me to see the points that I'm doing. Now, let's make our line blue, and let's make this line blue. And so now you'll be able to see the exact points that I'm graphing. Are you ready? Okay. Oh, I guess I have to get off the lines and go back to writing. Here we go. Okay, so we're going to pretend I hit that point. Okay, so I'm just putting some points that you can see. This is some random graph of f of x. Okay, does it pass the vertical line test? Is it a function? I'm checking. Are you checking? Yes, it does. Does it pass the horizontal line test? Does it have an inverse function? I don't have to restrict the domain. Yes, it does. So can you graph the inverse? So your question, your problem says graph of -1. Okay. I'm going to give you a second. I'm not going to give you too long because you can pause it. But I'm going to find and label some points. So I'm going to go back 1, 2. This is -2, 0. You have to be able to label coordinates. Okay? I'm going back 2. I'm just going back 2 more to -4. I've gone down 2. Okay, this is the first key point you have to do. Here's another point up here. It's 0. I didn't go right or left anywhere, but I went up 2. 3. 1, 2, 3, 4. This should be 5. 4, 5. 1, 2, 3, 4, 5. 5, 5. And this one should be 6, 6. Okay. Every point has a graphed reflection across the y equals x, or simply the x becomes the y and the y becomes the x. If y equals x, that's what that means. All right, so let's graph f-1. So if you have the point, I'm starting at the bottom left. If you have a point, -4, -2. Where would you go if you're switching the x and the y? You would go to -2, -4. 3, 4. So -2, -4. -2, 0. Here we are next. I'm going to put a dot there. I just want to put a circle. -2, 0 becomes 0, -2. So I don't go anywhere. I just go 0, -2. What about this point? That's 0, 2. The x becomes the y becomes the x. So that should be the point 2, 0. Next, 3, 4 will become 4, 3. Those are getting a little too close together. I wasn't thinking. Okay, 5, 5 becomes 5, 5. 6, 6 becomes 6, 6. So they are on both graphs. Okay, what does this look like? A little hint. I'm actually going to draw. Let me go ahead and draw the y equals x line. Okay, the y equals x is going to be this line going this way. Okay, goes through the origin. This is my y equals x. So can you see how each point, how this point is reflected across that point? They'll be the same distance away. Okay? Also, where our original graph kind of does this little loop here, this one's going to do it back towards it. Okay? This one is almost a straight line. Kind of has a little bit outward. Okay? Then I go from point to point. From this point here, it's almost a straight line. So I'm going to kind of go almost a straight line. It kind of goes out. This one curves in towards it. So I'll curve in towards it. Okay? This one is barely above, but then it's going to go this way. Okay? So they will be the same distance from the y equals x. That's a graph of a function and its inverse. This green graph right here is the inverse function. Okay? You might get a graph like this where I give you points. Can you graph the inverse? That's all you're going to be asked to do. Okay? You do have a little homework to start thinking about today. Okay? I need you on a piece of paper to graph y equals sine x. I know you don't have your posters in front of you or in the back of the room, like I can see them. And y equals cosine x. Now I want you to do it from a specific point to another point. The majority of our graphs have always been one period from 0 to 2 pi. I want you to go from negative 2 pi to positive 2 pi. Okay? I want you to graph both of those from negative 2 pi to positive 2 pi. Okay? And then start thinking about, is it a function? Are they functions? Question mark. What about, are they one-to-one functions? Okay? If they are, that's great. If they're not, how could we or you restrict, be careful about this though. I still don't think that's how you spell it, but it seems right. How you can restrict each one's domain. The domain of each one. Okay? How will you do that? Start thinking about it. That's how we're going to come back on Monday and talk and do. So, can't wait to see you. Can't wait to hear what you're saying and chat with you online some more. Bye. Have a good weekend.